Hello everyone, welcome back to JD Science Prep. Today I'm going to be giving a short introduction to refraction and discussing how the index of refraction applies to some problems that we can solve. So the speed of light in a vacuum is mostly accepted to be 3.00 times 10 to the 8 meters per second. So what that is the highest or the fastest possible velocity that light can travel at in a vacuum. So again, a vacuum would be an area where there are no molecules for light to hit, and a really good example of that would be space. However, in other types of substances, the speed of light is going to be slower. So the speed of light depends on the substance it is traveling through. So even the air that we breathe on Earth is not a good idea of a vacuum, as there are molecules for light to hit and go through. So the ratio between the speed of light in a vacuum and the speed of light in a given substance is called the index of refraction. And we can find the index of refraction and speed of light in a given material with the following formula. Okay, so with the following formula. The formula that we're going to be working with today is just N equals C over V. So you may remember from a past video, we've talked about moles, where we have C equals N over V. We need to separate these two formulas and not refer back to one another as we work with these, as these are totally different concepts. So in this formula, N equals C over V, the N will refer to the index of refraction for a material. So that's just the ratio between the speed of light in a given substance and the speed of light in a vacuum. C is going to be the speed of light in a vacuum, and remember, it's going to be that constant. It's going to be that 3.00 times 10 to the 8 meters per second. And finally, V is the speed of light in a given material. So just a quick little tip before we jump into a couple examples. If you ever get a value of V greater than 3.00 times 10 to the 8 meters per second, you have done the question wrong, as the speed of light in a given material cannot exceed the speed of light in a vacuum. Okay, so if you get, let's say, 4.01 times 10 to the 8 meters per second for a value for the speed of light in a given material, you need to redo that question as you did it incorrectly. Okay, I'm just going to erase that, then we can jump into a couple of examples here. So on the right side here, we just have some known indices of refraction. Okay, so we have air. The ratio between the speed of light in air and the speed of light in a vacuum, we just have 1.0003. Another example here, we have water. So the ratio between the speed of light in water and the speed of light in a vacuum is 1.33. And all the way at the bottom here, we have diamond, where the ratio between the two speeds of light is 2.42. So the higher the value of index of refraction, the slower light travels through it. Okay, so that is a helpful tip when doing these problems. The higher your N value, the slower light will travel through that given material. Okay, so the higher the value of index of refraction, the slower light travels. I'll make that a little bit neater. There we go. travels through that material. There we go. Okay, so we have two examples that we can go through here. Number one, it reads, if the index of refraction for corn oil is 1.47, what is the speed of light in corn oil? So let's write down what we know here. The first and easiest thing to write down is our constant. So the speed of light in a vacuum, if you can remember that value, we just have 3.00 times 10 to the 8 meters per second. And we're given one more value as well, and that's going to be our N value, or our index of refraction for corn oil, which is 1.47. So the formula again that we're going to be using, we have N equals C over V. In this example here, we are given N and we're given C. So we're going to need to solve for our V, or speed of light in a given material. So let's write down that formula here. I'm just going to square off this space here. We have N equals C over V. Okay, and we'll have to manipulate. So once you do manipulate this formula to isolate for V, your final formula will just be V equals C over N. So let's work up here. I'll just draw an arrow. So let's fill in what we know. We have our C, which is that constant of 3.00 times 10 to the 8 meters per second. And then we also have our index of refraction for corn oil. Remember that question gave us it, and it can also be found in some known index of refractions as well. So that's 1.47. And if you type in 3.00 times 10 to the 8 divided by 1.47, you should get an answer of 2.04 times 10 to the 8 meters per second. Now let's just think about that number really quickly, see if it makes sense. This number here, so 2.04 times 10 to the 8 meters per second, it is less than our speed of light in a vacuum, which should be correct. Okay, so I like this answer. We can move on to example 2. So the second example, it reads, if the speed of light in a given material is 1.974 times 10 to the 8 meters per second, what is the material? So we can write down what we know. So again, we'll write down that constant, 3.00 times 10 to the 8 meters per second is always the speed of light in a vacuum. And we're given something different in this question. Rather than the index of refraction, we're given the speed of light in a given material, which is 1.974 times 10 to the 8 meters per second. So again, let's take a look at the formula that we're going to be using here. I'm just going to box this off. So we are going to say that N equals C over V. We have both values here. Our wanted variable is already isolated for. So let's just insert our values. We have N equals 3.00 times 10 to the 8 meters per second, and that is over 1.974 times 10 to the 8 meters per second. And if you type that into a calculator, folks, you should get an answer of 1.520. Okay, and the final step here, our question actually asks, what is the material? So we have an index of refraction of 1.520. What we can do with that is refer over to our known index of refraction or indices of refraction. And if we look on our list, we see that crown glass has an index of refraction of 1.52. So we can come to the conclusion that this material in example number 2 is crown glass. So the material is crown glass. Okay, that is a short introduction on refraction and just working with indices of refraction. I hope this video has helped.